Okay. Well, good afternoon all. So yesterday we have seen introduction to the composites. Like composites are the material where it is developed for multi-usage. So basically its use is for the lightweight materials and the low density materials, and to have the higher properties which we cannot get by the traditional materials. So now we have seen in yesterday's class, that is the composites. Composites are further classified as matrix, reinforcement, dimension, orientation. Okay. So under matrix, we have seen yesterday's the different categories like polymer matrix composite, metal matrix composite, ceramics matrix composite, and carbon-carbon composite, and intermatrix composite. So now let us see, today's class is only for the introduction of the composites, and that too particularly based on the matrix phases. So these matrix, as we have discussed yesterday, the metal matrix composite, polymer matrix composite, the ceramics matrix composite, carbon-carbon composite, and the intermatrix composite or intermetallic composites also. So now let us see. So yesterday we have seen, so now just in 2 minutes I'm just going to brief out. So after that I'm going to start with the applications. So this is the composite. Okay. So generally the composites are made up of the two categories. So these two categories, one is natural, other one is artificial or man-made. So artificial composites, okay, and natural composites. Okay. So natural composites are basically made of these threads, banana leaves, and ropes, which were used in the olden days, and these tree leaves, okay, and some of the which are similar to papaya leaves, and groundnut, and cashew nuts, shells. These are some of the natural composites. And artificial composites, today it has been entered into almost every sector, from domestic to scientific applications. In simple words, we can call it as bucket to rocket. Okay. So in almost every field, we are going to use the composites in present days. So earlier in the 17th century, before 17th century, it was believed to be a iron age. After that, it came the brass or a bronze age. Later, the aluminum age. Then the polymer age. Then today, we are having into the composite age. So composites are of the two types. One is the natural composites, other one is artificial composites. So these composites were known to the mankind from very beginning of the 19th century only, but it got more popularity at the beginning of the 20th century. So 20th and 21st century is completely made up of composites. Now in present day, these composites, again they are in the verge of ending, and now a new trend has come, the hybrid composites, where you are going to combine multiple materials and to get the hybrid properties. So what are these hybrid composites? These hybrid composites are nothing but, under certain conditions, they behave like one property. Again, if you change those a set of working environment, then again the same material, the properties will change. Means in a single material you will be having dual properties or multiple properties depending upon the requirement. So nowadays, earlier the days were for the smart materials you need to use certain type of materials. Now traditional materials were different, advanced material were different. Now all those independent individual materials have gone, all those have been combined under a single category. So a material can be developed which can behave differently under different working or the different atmospheric conditions. So different atmosphere, different property. Once the atmospheric condition change, means the localized atmospheric condition changes or the surrounding changes, again the property of the material will change. Okay. So it is developed by the artificial composites. So now we are going to see a study about the artificial composites. So these composites are developed as per the human requirement. Earlier, whatever the material we used to have, we need to use and apply that particular material for certain applications depending upon the factor of safety, Poisson's ratio and the design criteria. Now, whatever the design criteria I want, correspondingly I can develop the composite material and use for the specific application. So this has reduced the optimization of the material. So earlier it may be used to over design or under design. So a limitation in the material was in the limitation of the material. So I was going to develop my design like anything, but corresponding material were not available. So now I can develop a material so as per my design. So that is what the advantages I got under this composites. So this composites, as we have discussed earlier, so it can be of 1 dimension, 2 dimension and 3 dimension also. So this composite is nothing but it's a combination of matrix and reinforcement. So basically a matrix is a bulk material and which is very soft in nature, low strength of properties and low properties of everything. Then reinforcement is the smaller element which is added to increase the strength of the matrix, and which is the volume is less and the strength is high, or other properties are very high and some properties will be very less. So now I am going to combine the properties of matrix and reinforcement. So when I combine this matrix and reinforcement, it is called as composite. So this composite is also called as tailor-made materials. Okay. So that is what I was speaking about, the natural and artificial composites. So natural composites is nothing but the traditional composites. Artificial composite is nothing but the synthetic composites. Okay. So as I was telling you about the primary material is nothing but the matrix material, and the secondary material is the reinforcement material. Okay, so this is what yesterday I was discussing about what are the properties of the matrix and what are the properties of the reinforcement. When I combine two different materials like matrix and reinforcement, I am going to get the composite. So, but the property of these composites can be varied depending upon what type of element we are going to use. So, this element can be of a metal or a ceramic or a polymer. So, if I am going to use the type of metal, then the property is going to change. Then if I am going to use the different size, again properties will be going to change. Again, when I optimize the size, again if I change the shape of the particles, again the property will be changing. So again, depending upon the type of operating parameters, again the property will be changing. So these are the advantages of the composite materials. Okay, so this is what yesterday we have seen. Okay, so these are some of the characteristics of a primary phase, that is the matrix material. So basically the matrix material is very bulk in nature and the volume is more, the property or like strength will be less, the ductility will be high, or the density will be low, and so here majority of all the properties will be lower. So these are some of the characteristics of the composites. Sorry, that is matrix material. So now I'm going to show you the applications of metal matrix composites. So now, which are the material which are being used most widely for any industrial applications? So for industrial applications, the material which are used is majority of the material which is used is aluminum. So aluminum is a type of material which is very soft in nature, which is very ductile, and the strength is less, and the density is also low. So now I should develop a material such that which is made up of aluminum because of its low weight, and the drawback of aluminum has to be increased. So the increase of the strength of aluminum can be done with the help of adding high strength material like titanium, tungsten, okay, or some ceramics. If I am going to use the metals, so I should use the steel, that is steel material, titanium and tungsten. So even some percentage of silicon and phosphorus also I can use, but the contribution of silicon and phosphorus will be less, but these less in composites, but these contribute very high in case of alloying. So again, that's a different aspect. Let us see at later stage. But here, when I'm going to use this aluminum, so I can make the strength of aluminum greater than steel. Okay, so it will be very tough to imagine how can the strength of the aluminum can be increased better than the steel. But in reality, it is possible by adding some of the elements and processing it. So those elements are the titanium and tungsten. So it is not that easy to add the tungsten and the titanium into the aluminum and get the strength, then everybody would have done that. But basically, by adding these in a certain proportion and certain atmospheric conditions and certain operating parameters, then you can get the better results compared to the steel. So this is what the advantage of using aluminum. So as we can see, aluminum, the density is low. By adding the reinforcement like titanium and the tungsten, where the density of those are little bit high. But if I am going to use completely of the steel or the titanium and tungsten, where the density of those are almost 3 to 4 times or sometimes 5 times better than the aluminum. So that becomes more bulky and it will be over designed. So I don't really not need of that material. So I can use the small percentage of titanium and tungsten in very 3 to 5% or maximum up to 10%. Then I can get the same strength that of a steel material. So that is one of the advantage. So here the addition of steel is reinforcement material, and the base metal or the primary material is the matrix material. So that is aluminum. Okay. So here I am going to discuss about the characteristics of a metal matrix composite. So now you can see basically these metals are crystalline in nature, and these get solidified only in the liquid state. So as we have studied in the casting process, any addition of the one element in the other element is done only at the liquid state. So in liquid state, the material solubility will be better. So but now what will happen by adding the titanium or a tungsten to aluminum, so not in the liquid state but in the solid state, again the processing parameter will change. So because of this, what will happen? Both are crystalline in nature, and the end product will be also crystalline in nature. And the second is the characteristics of metal matrix is it is ductile and malleable. Now you can see the steel utensils or any the boilers. So what we get from the rolling, the output of the rolling process is in the form of sheets. So that sheet cannot be used. Now that sheet has to be converted into the required shape and size. So then if I want to give the required shape and size to that plain sheet, so it should be having the ductility and malleability. Okay. So if only it is malleable, then I can give the shape of the utensil or maybe the boiler or some corrugations on the sheets, or else it will fail. So for that, the metal should be very, very malleable. Next comes to the ductility. So ductility by drawing process or by extrusion, again direct extrusion or indirect extrusion. So this metal, when I am going to apply large quantity of compressive force, then what will happen? Other side the material will be squeezed out. When it is squeezing, it should not break. So it should come continuously. So if it comes in the discontinuous, then it loses its drawability or the ductility. So if you can imagine the gold material, so it should be very soft, it should be very ductile in nature, so it can be drawn into the thin wire. So that is one of the advantage. So next, basically these all the metals are conductive of heat and electricity. So the conductivity might be different, okay, the range might be different, but basically they are conductors in nature. So you can take the examples of aluminum, copper, silver, okay, and gold. These are the best conductivity of electricity. But if you can take the titanium, tungsten, steel, no doubt they are also a conductors, but not good as the silver and gold. Okay, so some of the thermal conductivity. Okay, again the gold, silver are better compared to the aluminum and copper. So copper also nowadays it is not used majoritarily, so it is used aluminum because of the cost criteria. Okay, only this gold is used only in the printed circuit boards where the accuracy and precision is required, where the amount of heat transfer is very, very minute and the precision transfer is required. So there the gold is also used. Again, the amount of gold what is being used is also very, very less because of the cost criteria. Okay, so the characteristics of one more characteristics of metal matrix composite is it can be the shape. Okay, the shape and size should be given very easily. Okay, so these metal matrix or the metals are in solid, they are in solid state at the atmospheric conditions. So if you heat them over a melting point, then they become the liquid state. Okay, so they have the higher working temperature. When you compare the metals and non-metals, so generally the metals have the higher working range. So now you can see these are some of the examples of metal matrix composites. Okay, now you can see these are the examples, the engine blocks, the cylinder heads, the pistons. Okay, so these are the piston cylinder liners, these are the piston. So these are the engine blocks, so where it is used in the automotive industries. So like this, even the crankshaft, connecting rods, the piston rods, so everything, so these are the disc brakes, okay, connecting rod, fan blowers, camshaft, all these are the pistons, disc brakes, connecting rods, okay, the push rods. This is made up of aluminum, magnesium alloy and also composite. So you can see the compared to the Ambassador car and today's Maruti 800 car. So you can compare these two. No doubt both are four-wheelers, but this is very, very light in nature. So how that lightness have been obtained from the Ambassador car? It is basically by reducing the weight. So how the weight has been compromised without compromising the safety of the vehicle? So this is done through the aluminum magnesium alloy. So the function of the Ambassador car and the Maruti 800 car both are same, but there is difference in the efficiency and the quality. So this is obtained by the alternate material like composites. So these are gas turbines. Okay, so gas turbines, the impellers, the turbine blades, so the connecting rods, piston rings, all these are the examples. Now the landing gear. The landing gear of an aeroplane, okay, this is used in the junction of the steel structures. Now these are the ropes which are used in the JCBs, the cranes there. So next is the polymer matrix composite. So basically polymers are the material which are very light in nature, low density and having the low strength. Now the strength of the polymer has to be increased or enhanced. Okay, so now we can see these are some of the applications of polymers. So now here you can see the wind turbine blades. So the length of the wind turbine, each blade is in terms of meters, 5 meters, 10 meters, 15 meters, depending upon the height and wind velocity. So even at that high wind velocity, it should have the sufficient stiffness. So that stiffness we have to obtained by the polymer. Here you cannot use the metal. Okay, so what is the alternate material to the metal? Then you come to polymer. As you know, the polymer is having very low strength. Then how to increase the strength? So then you add the fibers into the polymer. By adding the polymers, what will happen? The strength increases. Again, the strength in X direction it will be different, in Y direction it will be different, and the Z direction it will be different. That is, the three-dimensional body, the arrangement of fibers in matrix, how it is arranged, accordingly again the strength increases. So the tensile force, the compressive force, shear force, everything varies. So that is obtained, okay. So this is obtained with the help of the fiber composite. So the fiber is reinforced in the polymer. So next is, now you can see the Tata Nano car. So the front windshield is made up of again a composite. So as you can see, the Tata company has declared or announced that they will bring the car, okay, into market within 1 lakh rupees. So all other companies which were into the market, they were selling the car by 3 to 4 lakhs rupees minimum. Okay, so even the Maruti 800 at 5-6 years back, they announced that their pricing was 4 to 5 lakhs. But Tata came up with a concept where they will launch within 1 lakh a car. Then how to optimize that? We cannot compromise in the engine, the quality of the engine and the functioning of a automobile. So what you need to do is you need to reduce large quantity of weight. Then how to reduce the weight? Then what is the alternative to the weight? What materials have to be used? So without compromising the quality of the vehicle. So then it gave rise to the majority is composites. So again in composite, majority is contribution is done by polymer matrix composite. So this is the fan blades. So the interior of an vehicle. All these are the examples of the composites. Okay. Now you can see these the cell phones, the casings of the cell phones, the golf stick, the mobile phones. All these are the applications of polymer matrix. So even in our domestic household, we can see the racks, doors, okay, the chairs. All these are polymers. So now you can see this the Wimbledon. Okay. So this thin wire can hit this ball at an velocity of 100 meters per second. So whenever the strike is done, okay, or whenever the servicing is done, where the large impact is done on the ball, and this ball travels at minimum 60 to 70 kilometers per hour. Okay, so with that speed when it is traveling, that impact is generated by very thin wire. And again this wire is made up of the fiberglass wire, which is put by the polymer. Again that is a composite. Even this racket, okay, so you cannot use the metal frame. So what you need to use the fiber frame. So because the weight will be less. When the game is going on, so they play for 45 minutes to 1 hour normally. So you cannot hold a heavy weight racket in the hand which is made up of the metals. So what is the alternate for this? Then you go for the fiber glass frame. Okay. Then this is the helmet. So now you can see the helmets are made compulsory by the government for the human safety. But if this helmet is made up, imagine if it is made up of a metal, then the weight of this helmet will be like almost 4 to 5 kgs minimum. Then you need to wear 4 to 5 kgs and then travel over a distance of maybe 50 kilometers, 100 kilometers if you are going for the out of station or for a race, then which is very uncomfortable in nature. So the weight of this should be as low as possible. At the same time, the safety should be there and there should not be compromise in the safety. So this helmet, okay, absorbs a large quantity of compressive loads and also the shock loads, that is impact load. At the same time, it keeps the human very safely. So that is what the advantage of this. The rugby ball, okay. So as you can see, the rugby ball, where it is a group event, so group game. So when many people fall on each other where they are holding the ball. So even Similar cases, if you take the football or other game, if you put large quantity of weight on it, then that ball will tear off, whereas this will not tear because this is made up of fiberglass. Okay, so fiber rubber, and this is skiing, and this is pole vault. Okay, so pole vault where the person comes and jumps at the feet of 10 meter, 15 meter, 20 meter. So by using the support of this pole, so that is why it is called as pole vault. Okay, so it should have sufficient stiffness and bending, and it should not break. Imagine a person who is jumping, he is at the very peak, and that stick breaks, then what will happen? So he collapses. So he falls down and collapses. So because of that, it should be very, very bending in nature. So that bending is obtained by the stiffness property. Then this bow, the skying, all these are the examples of the polymer matrix composites. Again, these composites are classified into two categories, that is thermosetting plastics and thermoplast plastic. So thermosetting plastics are the plastics which are which cannot be used again and again. So it is one-time process. If you want to understand a simple thermosetting applications, now you can take the examples of these electric buttons, okay, electric switches, electric regulators. All these are the examples of thermosetting plastics. So earlier days, bakelite was one of the popular material which was used for the electric buttons. Nowadays that has been reached by the different materials. So like thermosetting materials. Okay. So this is a one-time process. So you cannot reuse again and again. So another type of classification is thermoplast. So this is very soft in nature and you can reuse again and again. So without compromising the quality. Quality, it means the properties of the material. So those type of material are called as thermoplast. And next is ceramics matrix composite. So here basically the ceramics are used as the base metal, and the basic property of the ceramic is very brittle. So you just take any ceramic material and just drop it, okay, so it is broken into multiple number of pieces. So by this what will happen, whatever the money and time you have invested, everything goes into vain. So what is the advantage of these ceramics? Basically ceramics are having very high strength, that particularly the compressive strength, but they are weak in the tensile force. So if I want to increase the strength of this, okay, already they have been sufficient strength they are having, but the ductility is very less. So now what to do when I drop it, because of that impact it is going to fail. Now that impact should be absorbed by the material. It means that the material should be sufficient ductile. So now you can see this material okay, this is stress, this is strain, this is basically a brittle material. So when I am going to apply the force on this, this is going to have the brittle failure. So this is the brittle failure. So if I want to convert this to a ductile material, then I should add some of the absorbing material such that this becomes like this. So I have compensated little bit of strength, but my ductility has been increased considerably. So because of this, what will happen, the failure will be like this. The elongation will be very high. In this there will be no elongation, even though if it is there, it will be very, very less. So this type of material absorbs more energy before failure. This will not absorb energy before failure. So this is random failure, or the material fails without any warning. Here the material is giving sufficient warning because the necking is taking place. So because of this, what will happen, the elongation, at the elongation it is absorbing more and more force. So another example is there where the gold, okay, where the ductility is very, very high, and this is the failure of the gold material or a silver material. So it tries to retain its strength even up to the last crystal, okay. So up to the last crystal also it can maintain the strength. So the strength of an ceramic, okay, so is high, but the ductility is very less. Now I am going to add some of the material. Again, it might be a ceramic or it can be a metal, where the ratio of absorbance is very, very high. So as a result of that, the usage of ceramics can be put into various applications. So that is what the advantage. And one thing I would like to say here, so all these ceramics are basically oxides in nature. Okay, so that is why you can see aluminum oxide, silicon oxide, carbon, silicon nitrate, okay, boron nitrate, zirconium oxide, chromium oxide, okay, thorium oxide, all these are titanium oxide, all these are basically oxides in nature. And here, one more advantage of this ceramic is, whenever there is a application beyond 1000 degrees, then metals loses all its characteristics. So the maximum melting point of steel is 1539. So when it crosses 500 degrees, then the steel starts losing its characteristics. So you cannot use the steel material beyond 350 or 500 degrees centigrade. But if the application is such that where the temperature is beyond 1500, 2000 or sometimes 2500, then you cannot use the metals. The usage of metals has been completely ruled out. Then the only case which is left out is the ceramics. Okay, so ceramics are the material which can be used even at high temperatures. But the problem is, as the temperature increases, the coefficient of thermal expansion of that will be reducing. At the same time, they are too brittle. So that the brittleness has to be reduced of the ceramics. Then you should add the elements such that even at the high temperature, okay, where the susceptibility of breaking is high, they should not break, and it should maintain the shape, the size, position, and the required properties. Okay, so now these are some of the examples where it is being used. That is particularly the ceramics. Now you can see in this is the launching of an spacecraft. That is, whenever we are launching the satellite, no. So in that case, the launch pad, the base. Okay, so this is the base. So here, large quantity of fuel is burned, where the temperature is more than 2500. So there, if you are going to use the metal, then it is going to melt and it cannot fire. So here, the thrust force, what it is required, so it is obtained by the ceramic material. So what ceramic material, how it is processed, we will see it later. But now, as of you understand, so where is the application of these ceramics? Okay, so using these, you can choose the project as per your convenience. These are the clutch plates and the friction pads. This is the front nose of the aeroplane. Okay, so as you can see, when the aeroplane is moving, the jet plane is moving, or the rocket is moving at a very high speed. Okay, so it experiences large quantity of resistance. So because of that resistance, if you are going to use the metals, so there is a possibility of the material shatters off, and sometimes it peels off. Okay, sometimes because of the variation of the thermal cycling, because the temperature at the high altitude is very less, sometimes because of the sun it will be very high. So in that case, because of the variation in the temperature, which is generally called as thermal cycling, if the metal is going to be used because of the thermal cycling, you know that the coefficient of thermal expansion is high when you heat the material, the coefficient of thermal expansion is low or when you cool the material. So if there is a cyclic loading, then thermal stresses are generated in the metal. So because of this, what will happen, the material fails abruptly without any prior notice or without any the failure indication. So in that case, the large quantity of damage can happen in terms of money or in terms of life. So if you want to reduce that, then you go for the alternate material which is made up of the ceramic. Again, that particular ceramic is the ceramic composite material. Okay, so this is again the thrust force, the exhaust of a spacecraft. So now we can see, so in this case, so now the warplanes and the warships. So the ships is in terms of multiple number of meters, like 100 meters, 200 meters, sometimes a kilometer. So warships are generally like 800 meters to 1.5 meters, 1,050 meters. Okay, so in that case, lot of aeroplanes can be stored on the ship. So when the aeroplanes are taking a fly off or when they are landing, so large quantity of impact is generated on the surface of the ship. So if that ship is not, the base metal of the ship is not having the sufficient energy to absorb the impact of the aeroplane or the jet plane or the warplane, then what will happen? The crack is developed on the surface. If that crack propagates, then ship is broken into two pieces. Okay, so whatever the energy has put into develop the ship, that is going to be waste. Hence, so whenever there is an impact, so this material should absorb the energy which is generated by the landing of the aeroplane or the jet plane. So that is made up of again the ceramic materials. Okay, so next is the jackets, bulletproof jackets. Earlier the bulletproof jackets were weighing in terms of 10-15 kg. So a person who is wearing that for a safety purpose used to be very uncomfortable because of the weight. He cannot put on the weight 10-15 kgs and travel for a wear for a longer time or travel for a longer distance. So now that has been reduced by the ceramic material. So this is 0.4 mm bullet. So now this distance is hardly around 2 to 4 meters. So he is fired at that particular distance, and even this person is safe. And you can see the thickness of that. It is hardly in terms of 1 mm or 1.5 mm, and it is flexible and folding. So if you are going to use the metal, the similar properties, if the metal has to be used, so then we should use 10 mm the thickness plate. So when you are going to use the 10 mm thickness plate for a personal protection, so the weight of that will become around 10 to 15 kgs, and at the same time it is uncomfortable because you cannot turn or bend. So whereas in this case, all the flexibility is there, at the same time the weight is also less and the comfortness is also there. Okay, so by this you can understand what is the benefits of using the ceramics composite material. So next is one more type is carbon composite. So here the base is also a carbon and the reinforcement is also a carbon. So this has been developed very recently. So by this we can see what are the advantages of this carbon composite, where the strength of an material has been increased very tremendously. These are basically used threads or yarns. Okay, so these are used in the form of yarns. So now we can see this is a simple example of the tire, maybe the cycle tire or two-wheeler tire or a four-wheeler tire. So whenever we are riding the vehicle, so what comes in contact with the surface of the road is the tire, not the engine or any other part of the vehicle. First, what it comes with the surface of the road is the tire. So as the vehicle is moving, maybe whatever the speed, if in the city 20 to 40 kilometers per hour, outside the city like 60 to 80 kilometers per hour, and on the highways above 100 kilometers per hour. So when the vehicle is moving at 100 kilometers per hour, roughly for an assumption, if it is run for 1 hour, 2 hours, 4 hours, 6 hours, as you are going to run very fast and for a longer distance, large quantity of heat is generated at bottom surface of the tire and top surface of the road because of the friction. So this will lead to the wear and tear of the tire. Okay, so at the same time large quantity of heat is generated, and we know that whenever there is a generation of heat, the material becomes soft. So in that case, if a small nail or any sharp material, if it touches the tire, then it becomes cut or it becomes a puncture. Or sometimes there is even the possibility is there, the tire gets blast. So when this happens, what will happen? So the possibility of survivability of the passengers who are inside the vehicle when they are traveling on the highways above 100 kilometers is very less. Okay, so now can I improve the property of a tire such that even at the 100 kilometers per hour or 150 kilometers per hour, it should not happen anything? So we can see on the foreign roads in the US and the Gulf countries where they travel very comfortably in 150 or 200 kilometers per hour. So if we take the race bikes or the race cars where they travel 300 kilometers per hour. Okay, so what is the difference? So they are using the quality material. So that quality material is nothing but the composite material. That particular composite is the polymer composite or the rubber composite. So polymer, rubber is also a type of polymer. Generally it is called as elastomer. So polymer has been into two categories, okay, elastomer and monomer. So this elastomer comes here. So these all are the elastomers. So that is basically a rubber in nature. So this is also a carbon, means the base metal is also a carbon, and this reinforcement means the fibers or the threads or the yarns, these are also a carbon. So carbon is added into the carbon. As a result of this, the strength increases. So even if you travel for 150-200 kilometers per hour, it is not going to generate heat, and the friction is also very good. Suppose if you want to stop the vehicle at very suddenly, so when you apply the brakes, the vehicle should stop immediately. Okay, so this is going to help. So this is the example of carbon composite. Now next is the skating helmet or the cycling helmet. So the weight of this should be very, very less, maybe in terms of few grams, not even the 100 grams. So less than that. So because when you are doing the skating, okay, or skiing or the cycling, the weight should be very less on the head. You should not feel the weight of a helmet. So even the polymer helmets, they are also in terms of 900 to 1.2 kgs. Okay, but this should be in terms of hardly few grams. Okay, so such that you feel the comfortable. And at the same time, it should be safe and no injury should happen to the head. Okay, so this is again the example of carbon composite. So this is the detailed structure of the tire. So now we can see. So this is the Mercedes-Benz car. Okay, they started making the use of these front bonnets. Okay, dashboards. Okay, so when the impact is to happen, so first it happens at the front only. So if this is made up of the metals, then what will happen? Whatever the impact is there, that it transfers the impact to the drivers or the passengers in the vehicle. So because of that, many people, though the accident is of the low severity, because of that, the impact is getting to the transfer to the driver or to the co-passengers. So because of that, they are going to die. So if that impact happens, if this breaks and the load gets distributed sidely, so no load is transferred to the passengers. So because of that, these are made up of carbon fibers, and these are almost stronger than the steel materials. Now you can see these are also springs. These are the coil springs. So generally what we see is the spring steel. So there is a separate category called as a spring steel, where the springs are made up of that particular material. So what is the characteristics of that? So it is having some stiffness, and because of that stiffness, it is going to give the cushioning effect. So basically springs are used for the damping or the absorbing the load. So here the weight of the traditional springs is very high. So in this case, I want the low weight. Okay. So if I use any other material like aluminum or the polymer, it is going to bend or it is going to break. Whereas this is not going to break. So this is the example of carbon composite. Now this you can see the mobile casing. So generally the mobiles are made up of electronic gadgets, and these are very costly. So some are few thousand, some are in terms of lakhs. If you go for the Galaxy or Apple iPad, so they go for 2 lakhs, 3 lakhs rupees. And even the Samsung Galaxy recent series like 50,000, 60,000 costly phones. So they are almost costlier than a 42 or 46 inch LED TVs. Okay, so that is what we are carrying in a hand. So by mistake, if it falls, then what will happen? It is going to crack. Means maybe the screen is breaking or some other components are going to break. So that much of costly item, so no need I need to handle with care, but sometimes by mistake or by out of sight it falls. Then all my 50,000, 60,000 rupees, sometimes lakhs of rupees, it is going to go in vain. So now if that material is developed by the composite material, even if it drops, so it will not break. Okay, just it will open up and it absorbs the impact energy by the drop test. Okay, so this is called as drop test. So it means that whenever a material is dropped at some certain height, it should not fail. Okay, so it will not fail when it is made up of carbon-carbon composites. So these are the shoes. Earlier days when I was a kid, when I am going to school, then every 6 months or 1 year I need to purchase the school shoes. Nowadays, from last 10 to 15 years, the generation has changed up, and now you can see the Nike, Reebok, Puma, Adidas, so many companies producing the shoes. So once if I purchase the shoes, so I'm going to use it for 5-6 years very comfortably without any failure, and I can twist it, bend it, I can wear it for mountaineering, so many cases. So whereas earlier shoes were not that flexible and they were heavy in nature. Okay, and every 6 months or every 1 year we need to purchase a new shoes. But nowadays that is not the case, because these materials, the sole material is made up of carbon composites, where you can bend it completely 180 degrees or even more than that. Not only that bending, you can also twist it. Okay, so now you can see this car. So what is the beauty of this car? Isn't it? What you can see in this? So it is nothing but it is a traditional car. Okay, what we see outside the college or anywhere in the world, what we see is the same car. But here the similar car and this car, there is a small change. That the change is in the tires. Now you can see what is this difference. So you can see the spokes, and this is the tire. This is the spokes and this is the tire. So now you can see, now we have seen the earlier the tires with the tubes and tires with the tubeless. So now you can see, you don't see both here. Okay, now you can see. So this is completely hollow in nature, and these are the spokes of the rubber. Okay, tire rubber. So whenever it is bending, so it is going to take that particular shape. So this can travel very comfortably on the steps also. So now because of this, what will happen? So this can be run at 250 kilometers per hour. So this has been tested in the Germany also. So this has been tested around 5 years back. So it can travel 250 kilometers per hour. So here there is no question of refilling the air. Again, nitrogen, nothing is required. So there is no question of your blasting of the tire because of overheat, friction, no case. And here, what is the advantage here? So no puncture. So your tire cannot get punctured. And in other way it is efficient, the weight is less. When the weight of the vehicle is less, the efficiency of the mileage is again high. And other reason, other advantage is, so here, whatever the dampening happens, so when the tire gets bent, some cushioning happens here. So as a result of that, the spring what you are going to use in the vehicle, so that stiffness can be reduced, so that low stiffness springs can be used. So some stiffness, some shocks or some vibrations have been absorbed here only. So as a result of that, so minor vibrations are observed here only. As a result of that, you don't, those vibrations are not transferred on the passengers. Okay, so this is manufactured by the Michelin, and this is what the structure of an tire. Again, this is made up of carbon composite. Now you can see. So this is the waste tires in only one city. Now when you go outside the city, you can see in the dump yard, so many tires are thrown away. So when you burn all these tires, so you can see large quantity of carbon is generated. That carbon is nothing but the carbon dioxide and carbon monoxide. So again, this adds so much of pollution to the environment. So this is the position of just one place. Now if you can count a number of districts, okay, states, country, and throughout the world, how many tires are there, and if you are going to burn, how much carbon dioxide is used. So we can reduce all this wastage by using smaller quantity of carbon. So that is what we have seen in the earlier case. So these are the advantages of the carbon-carbon composites. So next is the intermatrix composites. So this intermatrix composite is nothing but whenever I am going to use this, so whenever I am going to use this composite, okay, so again it is having two different components. One is matrix phase and these are reinforcement phase. These are reinforcement. So there should be proper bonding between the reinforcement and the matrix. And that particular bonding happens on the surface of the reinforcement. If the proper bonding is not there, then what will happen? This reinforcement will come outside of the matrix material very easily. So the function of reinforcement in the matrix is of no use. For example, now you can see this beam here. So this beam is having the combination of the matrix and reinforcement. So here the matrix is the cement, sand, jelly, water, all these are basically a matrix material, and the reinforcement is the steel material. So the steel bars is starting from one end to other end. Suppose if the bonding between the steel and the remaining material it is not there, if you hold one second outside the steel and just pull it, it will come from one end to other end completely outside. So as a result of this, what will happen? So whatever the strength of your column beam has been designed, it will fail immediately. Okay, because there is no bonding between the matrix and the reinforcement. Okay, so once both are there, okay, so the matrix and reinforcement both should act as a single element. So that will act only when the reinforcement and matrix both are compatible in nature. So that sometimes the compatibility is not there, sometimes it is there. So for example, now you take two pieces of paper, just keep on one above other and you apply the